All right. Welcome back, everyone, to the deep dive. We're constantly bombarded with talk of AI this, AI that. But today, we're going beyond the hype to explore something even more intriguing.
We're diving into intelligence augmentation, IA.
Exactly. IA. And to guide our deep dive, we're turning to this fascinating article, Artificial Intelligence, AI, or Intelligence Augmentation, IA. What is the future?
It's a great piece, really delves into the core of these concepts and asks some thought-provoking questions.
Absolutely. Our mission, and we chose to accept it, is threefold. First, to break down the differences between AI and IA, what sets them apart.
Right.
Second, to peer into the future, speculate a bit on where each might be headed.
The crystal ball, always a bit cloudy, but we'll give it a shot.
And third, and perhaps most importantly, to grasp what the research, the experts are saying about the ultimate goal here. Like, where is all of this leading?
That's the million-dollar question, isn't it?
Now, let's be real for a second. Even defining intelligence itself is a bit of a head-scratcher. This article mentions Legg and Hutter, who compiled, get this, 70 different definitions of intelligence.
It highlights just how multifaceted a concept it is. But, for our conversation today, a couple of definitions really stand out.
Okay, lay 'em on me.
Well, Jensen, building on Bereiter's work, described intelligence as, and I love this, what you use when you don't know what to do. It's that capacity to navigate the unknown.
So it's not just about knowing stuff. It's about knowing what to do when you don't know.
Precisely. It's about adaptability, resourcefulness. And then we have Collum and his colleagues drawing on Snyderman and Rothman, who offer a slightly different perspective. They define intelligence as a general mental ability for reasoning, problem solving, and learning.
So more of a skill set focused definition.
Yes, exactly. And to round it out, Gottfredson adds that the speed of learning, how quickly you pick things up, and the ability to learn from experience, those are crucial aspects of intelligence as well.
It's fascinating how all these definitions, while different, emphasize the core human element. And that distinction between AI and IA, between machines independently solving problems and machines helping us solve problems, becomes super relevant when we consider the world we live in, the sheer complexity of it all.
It's relentless. The need for quicker, more efficient, and flexible solutions is constantly increasing.
And here's the kicker, right? Humans, well, we don't always make perfectly rational decisions. Even Nobel Prize winners like Kahneman and Thaler have shown us how biases and mental shortcuts can totally color our judgment.
It's true. We're not always the logical creatures we like to think we are. And in our attempts to grapple with all this complexity, we've gotten really good at building models, representations of abstract ideas.
But here's the catch. The data we feed into these models is crucial. If it's biased, incomplete, or just plain wrong, well, the outcomes are going to reflect that. Garbage in, garbage out, as they say.
Absolutely. You can have the most sophisticated algorithm in the world, but if the data it's working with is flawed, the results will be too. And it was precisely this need, the need to handle complex problems and make better decisions, that led to the emergence of AI back in the 1950s.
The whole idea of programming computers to behave intelligently.
Right. And from its humble academic beginnings, AI has, let's face it, exploded into our lives.
In a big way. Think about it. Speech recognition on our phones, AI-powered medical diagnoses, even self-driving cars are starting to become a reality.
It's mind-blowing how pervasive AI has become. And the article we're discussing today defines AI really well, I think. It says that AI is essentially a computer system that mimics human cognitive processes. It uses data to make decisions, and importantly, to learn from the patterns it identifies in that data.
So it's not just following pre-programmed rules, it's actually learning and adapting as it goes.
Yeah.
And this ability to analyze massive amounts of data is really being fueled by, well, the explosion of data itself.
Big data. And advanced analytics, the tools to make sense of all that information, are really driving the progress we're seeing in AI. The article goes as far as to say that AI is a key invention of the fourth industrial revolution.
It's that fundamental. And it's interesting how the very definition of AI has evolved over time. Dean and his team defined it as the design and study of computer programs that behave intelligently, while Winston focused on the study of ideas that enable computers to be intelligent.
It's all about imbuing machines with intelligence, but the emphasis has shifted over the years.
More recently, the definition has contrasted the creation of intelligent machines with, the natural intelligence we see in humans and animals. It's about creating something distinct from ourselves.
A new form of intelligence. And that leads us nicely to intelligence augmentation, or IA. Douglas Engelbart, a pioneer in computing, coined the term, and he envisioned IA as this middle ground, not about full automation, not about purely human effort, but about technology as a tool to enhance, to boost our own intelligence.
You know, it's funny, IA isn't as much in the public eye as AI. I mean, AI is definitely the buzzword of the moment.
It's got that Hollywood appeal, right?
Totally. But it's important to realize that both AI and IA fall under this broader umbrella of computationally based intelligence. You know, it's this field that's exploring how to create adaptive systems for intelligent behavior in complex and ever-changing environments.
It's about creating systems that can learn and adapt, whether they're purely artificial or designed to work in tandem with humans.
So our deep dive today, following the lead of this article, is all about examining the future roles of both AI and IA, not just for technology, but for humanity as a whole, and to really grasp their core similarities and, crucially, their differences.
Let's do it.
Okay, so let's delve a bit deeper into AI specifically. The article highlights the 1956 Dartmouth University Conference as a defining moment for the field. It was at this conference that AI was officially proposed as a serious area of research.
That was a pivotal moment, wasn't it? And the core idea was pretty bold, that almost any aspect of learning could be accurately described and then replicated by a machine.
Pretty ambitious. And in those early days, there were some notable successes. Programs were developed that could solve algebra equations and even understand some basic English.
It was the start of something big. And fast forward to today, well, we've already touched on how deeply AI is embedded in our lives, from voice assistants to medical diagnosis to self-driving cars. It's all around us.
And at its heart, AI is about pattern recognition. Computers identifying patterns and acting based on the data and statistical models they've been trained on.
It's about finding order in chaos, essentially. And the article provides some really compelling examples of what AI excels at right now. Take voice recognition, for instance. Alexa, Siri, Google Assistant, they're often incredibly accurate at understanding what we're saying.
It's amazing how quickly that technology has improved, from clunky, frustrating interactions to something pretty seamless most of the time.
And then there's pattern recognition across various data sets, like in finance or marketing, monitoring industrial processes to optimize efficiency, detecting faults before they cause major issues, even predicting future trends. The applications are really diverse.
And the potential in healthcare is huge. AI is being used to improve treatment protocols and personalize medicine.
Absolutely. And what's fueling all this progress? Data. Massive amounts of it. The Internet of Things, all those interconnected devices generating data constantly, that's what's making these AI models so powerful.
It's like AI is thirsty for data, and the IoT is a fire hose.
Haha, good analogy. Now, the article presents a couple of different ways to categorize AI. One is based on how AI's capabilities compare to the human mind.
Okay, so like a scale of intelligence.
Exactly. There are 4 categories here. First up, we have the reactive machines. These are the most basic type of AI. They respond automatically to a limited set of inputs, but they lack memory. They can't learn from past experiences.
So think of IBM's Deep Blue, the chess-playing computer that beat Garry Kasparov back in '97. It was a huge achievement at the time, but Deep Blue didn't learn from its past games like a human would. It just calculated possibilities based on the current board position.
Precisely. It was purely reactive. Next, we have limited memory machines. These are the AI systems we interact with most commonly today. They can learn from historical data to inform their future decisions.
So chatbots, virtual assistants, self-driving cars, they all fall into this category.
Exactly. They're constantly analyzing data to refine their performance, but they don't have a deep human-like understanding of the world.
They're great at what they do, but they're still limited.
And then the next level up is theory of mind AI. This is where things start to get really interesting conceptually. This is about AI systems developing the ability to understand the needs, emotions, beliefs, and thought processes of other entities.
Wow, so like AI getting a sense of empathy, recognizing that other agents, human or artificial, have their own internal world.
Exactly. But as the article mentions, this is largely a conceptual stage or in very early development. It's a huge leap from where we are now.
It's like the difference between recognizing a face and understanding what that person might be thinking or feeling.
A good way to put it. And finally, the fourth, and let's be honest, perhaps most debated category is self-aware AI.
The stuff of science fiction.
Right. This is the hypothetical end goal of AI research, machines that achieve human-level self-awareness, essentially a conscious machine.
So, like the Terminator, becoming self-aware and deciding humanity is a threat.
Haha, well, let's hope not.
Yeah.
But the article stresses that self-aware AI remains purely theoretical at this point. It's a long way off, if it's even possible.
Okay, so that's AI categorized by how it compares to the human mind. But the article also offers another categorization scheme, one that's more focused on the technology itself.
Right, and this one has three distinct levels. The first is artificial narrow intelligence, or ANI. Think of this as weak AI. It covers all the AI that exists today. AI that's designed to perform specific tasks within a narrow range of capabilities.
So your smart speaker that can answer questions and play music but can't write a novel or compose a symphony, that's ANI.
Exactly. It's really good at what it does, but it's limited to those specific functions. And the article connects ANI to those reactive and limited memory categories we talked about earlier.
So ANI is essentially the workhorse of AI today, doing a lot of heavy lifting, but within a defined set of parameters.
That's a good way to put it. Now, the next level up is artificial general intelligence, or AGI. This is often referred to as strong AI. It's the idea of an AI that can truly learn, understand, and function intellectually on par with a human being.
So an AI that could perform any intellectual task a human can.
And in theory, yes. The key difference from ANI is that AGI would be capable of general intelligent actions, not just specialized problem solving. It's the holy grail for many AI researchers.
An AI that could truly think and reason across a wide range of domains, just like we do.
Exactly. It's a lofty goal, and whether it's achievable is still hotly debated.
It's mind-boggling to think about. And finally, at the very top of this technology-focused categorization, we have artificial superintelligence, or ASI. This is the idea of machines with cognitive abilities that surpass those of humans. So computers that are smarter than us in every way.
That's the concept. The article even brings up the Terminator as a pop culture example of ASI, which, might be a bit unnerving for some.
Yeah, not exactly a comforting thought. Now, this whole discussion of AI categories brings up a really interesting main question that the article poses. Does our current technology even deserve the label AI?
It's a good question, because a lot of what we call AI today is essentially analyzing huge data sets based on pre-programmed rules. Is that true intelligence or just very sophisticated automation?
Right. The article suggests that maybe algorithmic or automated intelligence might be more accurate terms for what we're seeing right now.
And the article quotes Andrew Ng, a leading figure in AI, who says that right now, 99% of the value created by AI today is through one type of AI, which is learning A/B or input to output mappings. So it's about recognizing patterns and making predictions, but is that truly intelligent?
It's a good point. And this is where, as the article argues, Intelligence Augmentation, IA, comes into the picture. Because IA is about enhancing human intelligence, not replacing it. It's about using technology as a tool to empower us to make better decisions.
Exactly. IA is all about systems that support and augment human cognitive abilities. It's not about humans versus machines. It's about humans and machines working together, complementing each other's strengths.
It's a partnership.
Yeah.
And the article defines IA as the effective use of information technology in augmenting human intelligence. So it's not just about any technology, it's about technology specifically designed to enhance our thinking.
And a crucial aspect is that IA keeps the human at the center of the interaction with technology. It's not about handing over control to machines, it's about giving humans better tools to think and act.
The article uses the analogy of a GPS system, which I think is perfect. The GPS suggests the best route based on its data, but you, the human driver, ultimately decide whether to follow that route or not. You're still in control.
Right. You're using the technology to inform your decisions, but you're not blindly following it. And the article highlights how IA technologies are already being used to enhance human capabilities in various fields. It's about increasing productivity, automating mundane tasks, and generally making things easier and more efficient for humans.
So let's dive into some real-world examples. The article starts with IA in the enterprise. And one of the most exciting developments here is augmented reality, or AR.
Oh yeah, AR is huge. Smart glasses are already being used in industries like oil and gas, mining, healthcare, even the automotive industry. These glasses overlay digital information onto the real world, providing workers with critical data right when and where they need it.
It's like having an extra layer of information superimposed on reality.
Exactly, and the examples are really cool. Lenovo has these smart glasses called New Vision that are being used to improve safety and efficiency in coal mining.
That's amazing. What else?
Well, in healthcare, there's OrLens. These are AR glasses that are assisting surgeons in treating macular degeneration, a leading cause of vision loss.
Wow. And I read that FieldBed is using AR to connect on-site technicians with remote experts at companies like British Petroleum. So a technician working on a complex piece of equipment in the field can get real-time guidance from an expert who might be thousands of miles away.
That's a game changer for industries where expertise is often scarce and geographically dispersed. And even companies like BMW and Porsche are using AR glasses to assist their technicians with repairs.
It's like having an expert looking over your shoulder, guiding you through complex procedures.
Exactly. The article also mentions virtual automated assistants as another example of IA in the enterprise. These are AI-powered assistants that can handle tasks like scheduling appointments, managing emails, and even generating reports.
It's like having a super efficient personal assistant who never gets tired.
Exactly. Now let's move on to autonomous vehicles. The article makes a really important distinction here. It says that while current technology can automate driving in certain controlled environments, like highways, we're still a long way from fully autonomous vehicles that can handle all the complexities of the real world.
So Tesla's vision of fully self-driving cars is still a ways off.
It seems so, yes. The article points out that even with Tesla's advanced technology, a human driver is still required to be present and ready to take control if needed.
So we're not quite at the point where we can sit back, relax, and let the car do all the work.
Not yet. And one expert quoted in the article even argues that human input will always be necessary, even if it's remotely, to handle unexpected situations and make difficult decisions.
So it's not just about the technology, it's about the ethics and the complexities of decision-making in unpredictable environments.
Exactly. But the article also highlights some really promising research happening at MIT. They're working on bringing human-like reasoning to driverless car navigation. So instead of just following pre-programmed rules, these cars would be able to learn and adapt to new situations in a more human-like way.
That sounds like a big step towards true IA in autonomous vehicles.
It is, and it could have huge implications, especially for people with disabilities or illnesses that prevent them from driving. It could give them a level of independence that they wouldn't otherwise have.
Absolutely. Okay, let's move on to robots and the Industrial Internet of Things, or IIoT. The article talks about how robots are becoming increasingly important for IA, specifically in collaborative settings where robots and humans work together.
Right. Robots are really good at handling tasks that are dangerous, unsafe, or just plain repetitive for humans. And when you combine the precision and strength of robots with the creativity and problem-solving abilities of humans, you get a really powerful combination.
The article even mentions a framework called HAR, which stands for Human Augmented Robotic Intelligence. It sounds fascinating. What can you tell me about HAR?
Well, HRA focuses on the seamless integration of human and robotic capabilities, allowing them to work together efficiently and intuitively. It's about leveraging the strengths of both to achieve a common goal.
So less about robots replacing humans and more about robots augmenting human capabilities.
Precisely. The article also talks about how this pairing of robots and humans is being explored to improve health outcomes. For example, robots could assist surgeons with delicate procedures, or they could provide personalized physical therapy to patients.
That's incredible. And of course, we can't forget about the IoT, intelligent asset monitoring, where sensors and AI algorithms are used to track the performance of equipment and predict maintenance needs. That's another huge area where IA is making a difference in industrial settings.
Absolutely. It's about using data to optimize efficiency and prevent costly downtime.
And finally, let's touch on drones.
Drones. Another great example of AI enabling IA. The article highlights how intelligent, human-piloted drones are being used for a variety of applications, from inspecting infrastructure like cell towers and power lines to surveying remote areas that are difficult or dangerous for humans to access.
So the AI makes the drone smarter and more capable, but the human remains firmly in control, making the decisions and directing the drone's actions.
Exactly. It's a great illustration of how AI and IA can work together to achieve amazing things.
Okay, we've explored what AI and IA are and seen some real-world examples. But what about the core differences between them? The article dives into this, and it seems like the most fundamental difference lies in their objectives.
Right. AI at its core is often about developing autonomous systems that can eventually replace human cognitive functions.
So machines that can think and act independently of humans.
Exactly. Whereas IA is about using technology to supplement human cognition. It's about building tools that enhance our own thinking and decision-making abilities, but always with the human at the center.
So AI is about automation and potentially replacing humans, while IA is about collaboration and empowering humans.
That's a good way to put it. And the article points out that AI systems often perform best in highly structured environments where goals are clearly defined. Think of a game of chess or Go where the rules are fixed and the objective is clear.
But the real world is rarely so neat and tidy,
Well,
right?
exactly. And this is where IA can shine in situations where goals are less clear and information is incomplete or uncertain.
Because IA is about supporting human judgment and decision-making, not replacing it entirely.
Precisely. And the article quotes an expert, Rui, who says that while some see AI as a threat to human intelligence, others see it as a tool that can actually augment human intelligence. It's all about how we choose to use it.
It's a tool, not a replacement. And the article also quotes Jiang and other researchers who point out that the long-term goal of AI is often seen as enabling machines to think like humans, which of course raises the big philosophical question. Can a computer ever truly replicate the complexity of the human mind?
It's a question that has been pondered by philosophers and scientists for centuries. And it's not one that we're going to answer today, but it's a fascinating question to consider.
Definitely. And the article talks about how computer design goals have historically shifted between creating an artificial mind, which is AI, developing a mind tool, which is IA, and simply focusing on control and communications.
It's interesting to see how the emphasis has evolved over time.
And while we see impressive applications of AI, like thought-controlled prosthetic limbs, the article makes a really important point. Many of the technologies that are marketed to businesses as AI are actually functioning as IA.
Right. It's about enhancing human capabilities, not replacing them.
So it's not always about creating truly intelligent machines. It's about using AI techniques to make our tools smarter and more helpful.
Exactly. And the article describes this spectrum of human-machine interaction, from assisted intelligence, where machines repeat human tasks and humans make all the decisions, to augmented intelligence, where humans and machines collaborate on both actions and decisions, to fully autonomous systems, where machines act and decide independently.
So IA falls somewhere in between assisted and augmented intelligence, where humans are still firmly in the loop, making the final calls.
Right. And while some argue that IA is simply a new form of AI because they often use the same underlying technologies, the article emphasizes that the difference lies in their goals. IA prioritizes human involvement in decision-making, while AI often aims for a more autonomous system where technology is at the forefront.
But as the article argues, the human desire is for the extension and augmentation of our own intelligence. We don't want to be replaced. We want to be enhanced. We want to be better.
Exactly. And IA systems have an inherent advantage in that they can overcome the system boundary limitations that can hinder AI systems.
Can you explain what you mean by that?
Sure, AI systems often struggle when they encounter situations that fall outside their predefined parameters. But IA systems, because they involve humans in the loop, can adapt more readily to unexpected situations.
So IA is more flexible and adaptable because it leverages human judgment and intuition.
Exactly. And to sum up the core distinction between AI and IA, the article offers this really insightful analogy. AI wants to internalize artificial consciousness within a machine, while IA wants to externalize human consciousness using machines. AI focuses on the detached mind, while IA focuses on the mind and body in context. AI aims for independent machines, while IA aims for dependent machines, machines that depend on us.
That's a great way to frame it. And this dependency is crucial because it means that IA systems can handle situations where goals are ill-defined and inputs are uncertain, situations where AI systems often struggle.
Exactly. And the article even talks about this concept of human-in-the-loop augmented intelligence, emphasizing that because human life is inherently unpredictable, a complete machine replacement simply isn't feasible.
We need that human element to handle the nuances and complexities of the real world.
Right. And to drive home the contrast between AI and IA, the article includes a table that compares them across different domains like enterprise, autonomous vehicles, robots, and drones. It's a really helpful visual representation of these two distinct approaches.
Okay, so we've talked about what AI and IA are, their differences, and seen some real-world examples. But all of this requires massive amounts of data and processing power. What does the article say about the technology behind it all?
Well, it starts by highlighting the challenges of dealing with the ever-increasing volume and speed of data generated by all those IoT devices. Simply sending all that data to the cloud for processing might not be efficient or even possible in some cases.
Right, because of bandwidth limitations and latency issues.
Exactly, and this is where concepts like fog computing and edge computing come in.
Okay, can you explain those?
Sure. Fog computing is essentially a way to bridge the gap between the cloud and those IoT devices. It involves placing computing, storage, and networking resources closer to the data source at the network edge. This helps to reduce latency and improve reliability.
So instead of sending all the data to a centralized cloud, you process some of it locally, closer to where it's being generated.
Right. And edge computing takes this concept even further. It involves offloading computation to the very edge of the network, often to the devices themselves.
So the devices are doing more of the processing work themselves.
Yes, and this has a number of benefits, including lower latency, improved security and privacy, and increased efficiency.
The article mentions that edge computing could be particularly beneficial for expanding access to smart services in areas with limited internet access.
Exactly, because it reduces the reliance on a constant connection to the cloud.
So fog computing and edge computing are both about bringing processing power closer to the data source. But what's the difference between the two?
Well, fog computing is more of a hierarchical approach. It's about extending the cloud out to the edge, while edge computing is more focused on the devices themselves and their ability to process data locally.
So fog computing is cloud-centric, while edge computing is device-centric.
That's a good way to put it. And then the article briefly touches on this concept of mist computing, which is even more distributed computing at the extreme edge, like on the IoT devices themselves. It's more of a futuristic concept, but it's interesting to think about.
Okay, so we've covered the basics of AI and IA, their differences, the technologies that enable them. But now for the big question. What does the future hold for AI and IA?
The million-dollar question. Well, the article quotes Doraiswamy, who suggests that IA, with its emphasis on assisting rather than replacing humans, might actually be the real revolution. And it introduces this term augmented intelligence as another way to describe AI that focuses on amplifying human capabilities and creativity.
So not about creating artificial intelligence that surpasses human intelligence, but about using AI to enhance our own intelligence.
Precisely. And it's interesting that the article cites a prediction that general AI, the kind of AI that could truly think and reason like a human, isn't likely to surpass human intelligence within the next 60 years.
That gives IA a lot of time to develop and mature.
It does. And the article suggests that IA can actually leverage the outputs of those powerful AI algorithms to further enhance human performance. It's about combining the best of both worlds.
I like that, using the strengths of AI to boost our own strengths.
Right. And some researchers even use the term augmented artificial intelligence to describe this blending of AI and IA.
The article gives Grammarly as a good example of augmented AI in action. It uses AI to help writers improve their grammar and style, but it doesn't replace the writer entirely.
It's a tool that enhances human skills, not a replacement for human skills. And another example the article gives is Photoshop, which uses a combination of AI and IA to make image editing more powerful and intuitive.
So it's about using AI to make our tools smarter and more helpful, which then allows us to be more creative and productive.
Exactly. Augmented AI can automate a lot of those tedious, repetitive tasks, freeing us up to focus on the more creative and strategic aspects of our work. And over time, as AI learns our preferences and habits, it can offer even more personalized recommendations and support.
It's like having a super smart assistant who anticipates your needs and helps you work more efficiently. But the article also raises some potential downsides of augmented AI. One is that it could lead to a decrease in diversity of thought.
Right. Because augmented AI systems often rely on similar information sources and algorithms, there's a risk that they could reinforce existing biases and limit our exposure to different perspectives.
So instead of expanding our horizons, augmented AI could actually narrow them.
It's a possibility, and the article points out that there's also inherent subjectivity in building these IA models. The biases and perspectives of the developers can unintentionally be baked into the system.
And market forces can also influence how IA is implemented, further skewing things in certain directions.
Exactly. And this leads to a really interesting question that the article poses. As our interactions with the world become increasingly mediated by these intelligent technologies, how do we ensure that we maintain a clear distinction between what's real and what's artificially constructed?
It's a question of perception and how our understanding of reality might be subtly shaped by the tools we use.
Right. And the article takes this even further, asking about the potential for IA systems to become self-sufficient.
What do you mean by self-sufficient?
Well, could an IA system eventually reach a point where it can recreate its own environment, its own world, without any external input?
Wow, that's a mind-bending thought. And the article even speculates about what might happen if you were to combine a self-learning algorithm with the human brain, creating a feedback loop.
It raises profound questions about who is ultimately in control of our decisions and perceptions, and for how long.
The article paints a pretty stark picture, suggesting that the human brain could potentially lose its ability to distinguish reality from the projections of an intelligence-augmenting tool.
It's a cautionary tale. But the article also quotes experts like Lavenda and Kagel who believe that humans will remain in control for the foreseeable future, with AI primarily serving to support IA by processing those massive amounts of data.
So, not a Terminator scenario just yet.
Hopefully not.
Yeah.
And the article also reminds us that humans are incredibly adaptable. We've historically found ways to harness new technologies and navigate the disruptions they bring. AI and IA will likely be no different.
It's a reminder that technology is a tool, and it's up to us to use it wisely.
Exactly. Now, the article also delves into this concept of human in the loop, or HITL.
Oh yeah, HITL. What's that all about?
Well, HITL AI is essentially any AI model that involves human interaction in some way. It's about combining the strengths of both human and machine intelligence.
So leveraging machines' ability to process vast amounts of data with humans' ability to make nuanced decisions and understand complex situations.
Exactly. And in HITL AI, humans are directly involved in training, tuning, and testing the data that feeds those AI algorithms, especially in machine learning.
So it's a collaborative process, with humans guiding and refining the AI's development.
Right. And the article highlights the Zato's perspective that HITL AI is actually a fairer paradigm because it properly recognizes and values the contributions of those knowledge producers, the humans who are involved in the process.
It's about acknowledging that AI is not just about algorithms and data, it's about human expertise and judgment.
Exactly. And HITL AI combines supervised learning, where humans label data to train the AI, with unsupervised learning, where the AI identifies patterns in unlabeled data. It's a fusion of both approaches, with humans providing guidance and oversight.
So HITL is about finding the right balance between human and machine intelligence.
Right. And to wrap things up, the article emphasizes that while AI is undoubtedly a powerful force driving change in the world, education will be absolutely crucial in helping us navigate this new landscape. Host speaker.